we're going to look at graphing parabolas in these two very specific formats. First, I want to remind you that if your a value is positive, you have what I call a happy parabola. He opens up. And if your a value is negative, you have a sad parabola. He'll open down. The other thing that's important to note is if you have a plus or minus c on the end, that value is your vertex, and it is true to form. So if it is a positive value, you will go up that many on the y-axis. If it's a negative value, you will go down that many. I want to look at the graph of y equals x squared. First, notice that there is no plus or minus, which means that our vertex is at 0. You can think of that as x squared plus 0 if you like. Now, to find the points, the first thing is you could certainly plug a 1 in for x and see what happens. Plug a 2 in for x and see what happens. But there's actually a really nice pattern to this. If you notice, from the vertex to the first point is over 1, up 1. And that's true on both sides. To get to the next point, we go over 1, up 3. The next one, over 1, up 5. And if we were to keep going, as you can imagine, the next one would be over 1, up 7. As long as the coefficient of x squared is a 1, this will always be the pattern, regardless of whether the parabola opens up or down. Let's look at x squared plus 4. First, we have a plus 4. That means our vertex is up 4 units. Next, notice that this is a positive x squared, so we have a happy parabola. Next, the value in front of x squared is a 1. So, to find our other points from our vertex, we will go over 1, up 1 on both sides, and over 1, up 3 on both sides. And then, of course, we would connect that with a smooth curve. Here, we have negative x squared minus 2. This negative tells me that I have a sad parabola. He's going to open down. The minus 2 tells me that my vertex is down 2 units. Now, from there, since that coefficient of x squared is a 1, right? There's a 1 right there. We will use our 1, 3, 5, but we're going down instead of up. So over 1, down 1 on both sides, over 1, down 3 on both sides. And we can't get the 5 in, and that's fine. What about here when our coefficient of x squared is 2? Well, first, clearly it's positive, right? Which means we have the happy parabola. We don't have a plus or minus anything, so we have the vertex at 0. Now let's look at how we get from the vertex to the next points. So here we go over 1, up 2, and this one is over 1, up 6. Let's look at 2 and 6 for a minute. 2 is 1 times 2. 6 is 3 times 2. So there's our 1, 3. You can imagine that our next one would be 5 times 2. Where did we get the 2? The 2 comes here from the coefficient. So when you have a coefficient of your x squared other than 1, we can still use the 1, 3, 5 pattern, but we multiply by that coefficient. Let's look here. I have 3x squared minus 7. First, that's a positive 3x squared, so I'm going to have a happy parabola. Next, this is a minus 7, so my vertex is down at negative 7. Now, let's look. We would usually have 1, 3, 5, right? We won't bother with 7. We know we won't be able to fit that. Now we need to look at this 3. Since that's the coefficient, I'm going to be looking at 1 times 3, 3 times 3, and 5 times 3 to figure out how to get to my next points. So 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15. Going to my vertex, then to get to the first point, I'm going to go over 1 up 3 on both sides. Next would be over 1 up 9 on both sides. And again, we don't have room for 15 clearly, and you would definitely want to draw that out. Let's look at one more. Negative 2x squared plus 6. First, this negative tells me I'm going to have a sad parabola, right? He's frowning. Next, the plus 6 tells me that my vertex is going to be up 6 units on my y-axis. Now we have 1, 3, and 5, but the coefficient here is a 2. So we'll multiply the 1, the 3, and the 5 all by 2. So here I have 2, 6, and 10. And we'll go from our vertex over 1 down 2 on both sides, over 1 down 6 on both sides, and we don't have room for 10. And the nice thing is you can certainly plug in a point or two to check. We could plug in a 1 to be sure that we get the ordered pair 1, 4 if we wanted to. Not a bad idea to check, but this pattern will always work. I hope you found this helpful.